Don't forget to subscribe and ring that bell.
Booyah, booyah. Time for free response question number 4 of the 2013 AP Calculus AB practice examination that College Board gave to us. And, okay, we don't get a calculator, but we're good at what we do, so we're going to knock it out the park. Let's start. 4 reads, let f be the function given by f of x equals x squared minus 2x minus 1 all times e to the x. So it looks like we're just going to be doing a lot of work with that function right there. 4a asks us to find the limit of f of x as x approaches infinity and find the limit of f of x as x approaches negative infinity. All right, most of the time, when they ask us about functions approaching both infinity and negative infinity on free response questions, there's an exponent that's a variable. And what happens when we have a negative exponent? It flips in the fraction, meaning if it's in the numerator, we flip it and put it in the denominator to make it positive. There's a flipping. There's some flippage that's happening here. And let's just go ahead and do this. Let's start with positive infinity, okay? If I take the limit as x goes to positive infinity of x squared minus 2x minus 1 times e to the x, I really want to keep the biggest term in the top and bottom of my fraction. If I put this over 1, I mean, it doesn't make any sense. The biggest term would be the exponential, but I got to distribute that or whatever. I can keep just the biggest term in my polynomial and the biggest term outside the polynomial. And throw an infinity in there. I've got infinity squared times e to the infinity all over 1. I hope you realize that is just going to approach infinity. Okay, so infinity here, that's good. But where we need to be careful is when my variable approaches a negative value. And how come? Because in our function, we have an exponential. We have an exponent that is a variable, meaning I have x squared minus 2x minus 1 times e to the negative x. Oh, excuse me. It's positive x, but I'm going to put a negative infinity in it. Okay? So at this point, again, I'm going to put this over 1, and I'm going to keep the biggest exponent of my polynomial, and then my term that's outside the polynomial here. If I make those negative infinity, so I have negative infinity in for my x that I'm squaring, times e to the negative infinity. This is what I'm talking about. You need to be careful. Right here. All right? Know your rules for exponents. So whatever the negative exponent is attached to is going to flip. So I have negative infinity, that's still squared, over e to, now it's the positive infinity, okay? If I square negative infinity, it just becomes infinity. And I hope you know that bases to an exponent, okay, do not rise as fast as exponents do. Meaning this bottom will get bigger and bigger faster than the top will. The top will slowly increase, but the bottom will skyrocket up. And if the bottom of a fraction gets bigger and bigger and bigger, more so than the top, it approaches 0. 4a is now done. 4b. Find the intervals on which f is increasing. Show the analysis that leads to your answer. How posh. How proper, the analysis. Oh, just show your work, okay? So on which intervals is f increasing? First of all, if f is increasing, that means there is a positive first derivative. We need to find the first derivative of f, and we need to see where it's a positive value, all right? So they give us the equation for f when they give us the problem. Remember, recall that f of x is x squared minus 2x minus 1 times e to the x. So I want to find the first derivative of this function. Okay, let's start there. So the first derivative of x is, I've got to use the product rule. Okay, how come? Because I have one term or one function times another function. All right, so as I do this, I'm going to do the first, the x squared minus 2x minus 1. That's what I'm referring to when I talk about the first, times the derivative of the second. The derivative of e to the x is e to the x, plus the second just as it is, e to the x, times the derivative of the first. Okay, that's just going to be 2x minus 2. All right, well, let's clean this up, and maybe it'll be a lot nicer to evaluate. Because in order to find where our first derivative is increasing or decreasing, we first want to try and find the critical points. That's where my first derivative is equal to 0, and then I'll check the slope or derivative around those zeros or critical points. All right? So, if I distribute all this, e to the x, I can factor that out, but I can distribute this, then combine like terms, and things cancel, and factor out an e to the x again. Or I can factor out an e to the x first and combine what's left. I think we should factor out e to the x first and combine what's left. I think that would be easier. It's redundant to distribute e and then take it back out. You can do that. You can distribute the e, then take it back out. Or, let's factor this out. We have e to the x. What's left? This, x squared minus 2x minus 1, plus this. But now there's no e to the x in the middle there, and we will just combine like terms right there, which is going to make it easy for us. How so? Negative 2x and positive 2x cancel. So I've got x squared, a minus 1 minus 2 gives me negative 3. Yep, that's okay. That's a 3, children. I looked at the 2, I said 3, and I wrote the 2. So that's what's left in the parentheses, and we have e to the x. So this is still just the first derivative. It's simplified. Let's figure out where this is equal to 0. Right? So first of all, you should know right now that this will never equal 0. Okay, because I got to solve for 0 for both of these, right? Okay, e to the x will never equal 0, ever. Okay, even when my x value, the exponent is 0, anything to the power of 0 is 1. That will never equal 0. So I don't got to solve this part. Okay? I just got to solve x squared minus 3 equals 0. Now keep in mind you don't have a calculator, so keep it simple. We add 3 to both sides. X squared equals 3. And then I'm going to take the square root of both sides. And anytime you undo a square root, now keep in mind, how often do I say keep in mind? I don't know. But anyways, remember, you should know, okay? The square root of 2 is 1.414 something. The square root of 3 is 1.732 or something. This is about 1.7. Why is that nice to know? These are the critical points. Okay, I'm going to put that on a number line. Okay, and I'm going to start my number line right here. So this is negative radical 3, which is about negative 1.7. And this is positive radical 3, which is about a positive 1.7. My first derivative is 0 at both of these x values. What are they asking us in the question? Where f is increasing. I want to see where my first derivative, okay? Where's f increasing? Where the first derivative is positive. I want to see what values up here are going to give me a positive first derivative. All right, and keep in mind, this is even better. Not only will e to the x never be 0, e to the x will always be a positive value. All right, so if my first derivative is e to the x times x squared minus 3, this will always be a positive, and I'm doing multiplication. So a positive times a negative, okay, will result in a negative value. But a positive times a positive Well, it gives me a positive value. So really, I just need to check to make sure, when is this positive? Because that's where I'll end up with a positive times a positive, which is a positive, and that's what I'm looking for right here. Okay, now it's getting messy. Let's start plugging in some numbers. Okay, let's start with 0. If I put a 0 in for this x, and when I say for this x, I'm talking about this x right here. Because right now I only care about x squared minus 3. That's going to give me either a positive or negative value here, which will result in a positive or negative first derivative. Okay. If I throw a 0 for this x, 0 minus 3 is negative. These are negative. Okay? But what happens if I pick, let's say, I don't know, the number 2? When I throw a 2 in here instead of a 0, 2 squared is 4. 4 minus 3 is 1. That's a positive 1. All right? Let's check negative 2. Okay? If I throw a negative 2 in here, if I square a negative 2, it is still a positive 4. And a positive 4 minus 3 is still a positive 1. All right? So I'm looking at my first derivative there in those yellow highlights right here. When, on which interval is f increasing? Anytime it's less than negative 2, or excuse me, negative square root of 3. Anytime it's this way, I got a positive. Or anytime it's greater than positive square root of 3. So I just got to write that. Okay, let's state that. So when my x value is less than negative radical 3, or my x value is greater than a positive radical 3. Those are the only two times, the only two intervals where my first derivative is positive. Therefore, my function f is increasing. For C, and I believe question 4 only has 3 parts, A, B, and C, so we are done after this one. Find the intervals on which the graph of f is concave down. Show your analysis that leads to your answer. Okay, first of all, for 4b, they wanted to know when the function was increasing. That was when the first derivative was positive. For this question, for C, they're saying when is f concave down? That's when the second derivative is negative. Okay, it's a minus sign. I'll just say negative. Not a line. Okay, well, it's a good thing in part B we kind of simplified the first derivative. For 4b, we found out that the first derivative was e to the x times x squared minus 3. Okay, now I want the second derivative. So I want the derivative of the first derivative. And again, if you're not picking up on this, we have two functions, this and this. So we're going to do the product rule again. They're being multiplied, okay? It's the first times the derivative of the second. That's just 2x. Plus the second, just as it is, times the derivative of the first. The derivative of e to the x is e to the x. All right? And that is the second derivative. Now, what we want to do here, let's factor out that e to the x and combine like terms. It's the same thing we did in the previous problem. Or I should say 4b, which is technically the previous problem. I'm going to factor this out. I have e to the x, and what's left is 2x plus x squared minus 3. That's the second derivative. Now, it looks to me like that is a quadratic right there. Okay? So we're going to have e to the x. Let me write that in standard form. X squared is first, my positive 2x is next, and my minus 3. All right. Just like 4b, we had to set the first derivative equal to 0, which is where we find the critical points. And then we could find outside the critical points, on the intervals around the critical points, we found out where our first derivative was positive or negative. All right? Same thing applies here. In order to find when something's concave up or down, I need to find when my second derivative is equal to 0. Those are called inflection points. Okay, I'll put those on a number line. Then I'm going to check the intervals around those inflection points to see where my second derivative is either positive, or in this case, I want to know when it's negative. All right? So, oh boy, we got some work to do here. And it's not really a lot of work. But I want to see what this is equal to 0. Guess what? This will never be equal to 0, e to the x. We said that for 4b. Same thing holds true for 4c. So I really just got to find out when this is equal to 0. All right? Because this will never equal 0. I don't really got to solve for that, e to the x. So, okay, again, we don't get a calculator. Two things that multiply to -3 that add to +2. I don't know, how about a +3 and a -1? Okay, and buddy, I hate when the board does that. Let's T-bone that, set them equal to 0. X plus 3 equals 0, so x is -3. And x minus 1 is 0, so x equals a +1. These are where my critical points are. Those are where my second derivative is equal to 0. So I'm going to put them on a number line. You want to know why? Because I can. All right. Here's where x is -3. Here's where x is 1. X values. This is where my second derivative is equal to 0. I am once again going to check these intervals here, here, and here. And I'm going to see where my second derivative is positive or negative. Keep in mind, oh my God, children, please keep in mind that my second derivative, okay, when I factored it, it's x plus 3 times x minus 1. And then there was that e to the x that we really didn't have to do anything with. I want to figure out, well, where is this going to be positive? Where is this going to be negative? Okay, this e to the x, not only will it never be 0, it will always be positive times whatever this is times whatever this is. Okay, so really I just got to figure out what those factors are, multiply the positive and negatives together, and figure out if my end result or my product is positive or negative. So let's start picking numbers. Let's pick 0. I always like using 0. If I throw a 0, let's cut this off here. If I throw a 0 in for x, 0 plus 3 is a +3. 0 minus 1 is a -1. If I multiply a positive times a positive times a negative, my result will be negative. So everything above the 0 will be a negative second derivative. That's concave down. That's what we want. It's a sad face. Okay. Well, let's check the intervals on the outside, to the right of 1 and to the left of -3. All right, well, to the right of 1 is the number, I don't know, 2. You want to pick 12? You want to pick 3,876? Fine. I'm going to use an easy number 2. So on x is 2. I know this is positive. So now when I throw a 2 in here, 2 plus 3 is a +5. Okay, and if I throw a 2 in for this x, 2 minus 1 is a +1. If I multiply 3 positives together, my answer will be positive. So everything to the right of 1 will be positive. This is concave up. Smiley face. And last, let's pick -4. And let's throw a -4 in for our x here. We know this first term, e to the x, is always positive. If I throw a 4 in for this first x, 4 plus 3 is a +7. And if I throw a 4 in for this x, 4 minus 1 is a +3. Oh, man, look at me go. It should be negative. Oh, -4 plus 3 is a -1. And a -4 minus 1 is a -5. Okay, so a positive times a negative is negative. But a negative times a negative will still maintain positivity, like you should maintain positivity. Funny, I would have made a mistake if I did not catch that, but I still would have ended up with a positive answer here. That would have been fortunate. Okay, try not to make mistakes, but if you do, learn from them. Okay, so everything to the left of -3 is positive as well. Smiley face. The only thing they're asking us for is when it's negative or concave down. And there's one interval that I see from -3 to 1 is the only interval where my function is concave down. So I better write that. So from -3 to 1, box that in right there. That is it. Several different ways you can write it as two inequalities, whatever. You can write it out with words. I like using inequalities because it's less work. 20 minutes, we're done for A, for B, for C. I am out of here, and I will see you when we do problem 5, free response question number 5. Right, take it easy. It is December 21st as I'm doing this, so Christmas is coming up, or any of the holidays that you celebrate, whether it be Kwanzaa or whether it be, God, the dreidel, Hanukkah. Boom, that's it. Whatever you celebrate, okay, whatever you may celebrate, do it with family, do it with love in your hearts, and you know what? Be happy, be healthy, and stay safe. I will see you guys later.
Don't forget to subscribe and ring that bell.